Hi guys, tonight we're going to talk about polynomial functions and different attributes that they have. Let's get started. So first of all, vocabulary for you. The first thing you need to discover is called leading coefficient. The leading coefficient is the coefficient of the term with the highest degree. So another thing you have to remember is degree. Another word for degree is exponent or power. So first of all, let's go through these expressions here and try to figure out what the leading coefficient is. So looking at this constant, if I really wanted to, I could say that this is 12x to the power of 0. Anything to the power of 0 is 1. We don't necessarily have to write the 1, so that's why we just leave it as 12. The degree of this constant would be 0. When I look at this linear expression, I don't typically write a 1 here, but I'll write it for the sake of this. The degree is the highest exponent, so that would be 1. Here for quadratic, the highest exponent is 2, so the degree is 2. And then for this cubic, the highest exponent is 3, so the degree would be 3. That would be referring to the degree of the polynomial. When we're speaking on leading coefficient, so it's the number in front of that term with the highest degree. So that would be on this one just a 12 because there's nothing else there. All right, continuing there. For the leading coefficient of this linear function or linear expression, notice that I'm looking at the coefficient in front, so that would be a 4. The leading coefficient of the quadratic, remember it's the number in front of the highest power, so that one would be a 5. And then again on this cubic, the number in front of the highest power is an 8. So the leading coefficient is 8. So just if you have your expression in standard form, then usually your leading coefficient and your degree will come off of that first term. So just kind of keep that in mind. That's one of the other reasons why we find it important to be in standard form. This word right here is degree. I noticed that it's off the screen a little bit. All right, that says degree, the highest degree. All right. Moving on. So for this one, I want you to state the degree and the leading coefficient of each of these polynomials in one variable. If it's not a polynomial in one variable, explain why not. So go ahead and take a minute to pause the video and see if you can come up with the answer. All right, this first expression is in standard form with the highest power coming first. So I would say that the degree is this highest exponent here is 5. And the leading coefficient, I'm just going to put LC for short. The leading coefficient would be 8. For the second one, this is not a polynomial in one variable because if you notice, I have two variables right here being multiplied back to each other. So this one is not a polynomial in one variable. Not a polynomial in one variable. And then the third one, the degree is the highest exponent. So typically what y'all are used to is the degree being out in front, but that's not necessarily the case on this one. The highest exponent is 8. And the leading coefficient is in front of that term. So here's the full term right here, negative 4x to the power of 8. This is the term. So the leading coefficient is this negative 4. So the leading coefficient doesn't necessarily have to be the largest coefficient. It's just whatever's in front of the term with the highest degree. All right, let's move forward. Next, what we're going to do is use an equation to write a function value. So I have here, it tells me f of x is equal to x squared plus 2x minus 3. But we're to find this, f of 3x minus 4 minus 5 times f of c. So with that being said, you have to recognize that if something's in the parentheses, that means plug it in for x. So this, we're going to plug in for x. Plug in for x. So in this equation over here, everywhere I see an x, I'm going to replace it with 3c minus 4. F of 3c minus 4 equals 3c minus 4 squared plus 2 times 3c minus 4 minus 3. All right, this is going to take a little bit of work because on this first one, I'm definitely going to have to expand that a bit. 3c minus 4 times 3c minus 4 plus, I'm going to go ahead and distribute this while I'm thinking about it, plus 2 times 3c is 6c minus 8 minus 3. Let's distribute. 3c times 3c is 9c squared. I don't know, it's always hard for me to write 2's. 3c times negative 4 is negative 12c. Negative 4 times 3c, again another negative 12c. And then negative 4 times negative 4 is positive 16. And everything else, I'm just going to bring it down. Let's combine some like terms. I have these 12c's and then this 6c. So 9c squared minus 12, that's negative 24, plus 6, negative 18, c. And then I have 16 minus 8 minus 3. 16 minus 8 is simply 8. 8 minus 3 is 5. So plus 5 there. All right, so what we've figured out so far is this f of 3c minus 4. We need to now figure out negative 5 times f of c. So notice that negative 5 is on the outside of the f, so that means I'm going to multiply the outside by negative 5, or basically distribute negative 5. And for the x, I'm going to replace it with c. So negative 5 times f of c will look like this. Negative 5 times, everywhere I see an x, I'm replacing it with c. C squared plus 2 times c minus 3. So I'm going to just go ahead and work this out here. Negative 5 times c squared plus 2c minus 3. I'm going to distribute. Negative 5c squared minus 10c plus 15. And now I'm going to put that with what I found for f of 3c minus 4. So I'm just going to write it all out together. 9c squared minus 18c plus 5. And y'all know I like to line it up if I'm able to. Negative 5c squared minus 10c plus 15. So what would I get here? 4c squared minus 28c plus 20. So this is really a lot about taking your time and doing it piece by piece. Notice first what we did was f of 3c minus 4, figured out what that was. Then afterwards, we found -5 times f of c, worked it out, and then I put it together to get my final answer here. All right, let's go ahead and move on. Go ahead, take a minute or two, or however much time you need. Pause the video here and see if you can figure out these answers. All right, here's the answers to that question. If that was a little bit tricky for you, make sure to ask me in class and we'll definitely go over it if you have any questions. But I got 37a squared minus 75a plus 46. All right, here's the last little section that I want to go over with you. It's talking about end behavior of a polynomial function. So first of all, when we're working with our degrees, remember that's the largest exponent. Sometimes they're even and sometimes they're odd. So an even degree would be something like x squared. I always use that as my base reference. If the leading coefficient is positive, so for instance, positive 1x squared, then I get a nice quadratic that is going up on both ends. So both of these ends are facing up. What I need to know about that information to find the end behavior, it is written this way. I'm going to write as x approaches negative infinity. When I see this as x approaches negative infinity, all I'm really thinking is left arrow. The left arrow over here. As x approaches negative infinity, so basically, when I look at my left arrow, y approaches what? So in these instances, I'm basically thinking, is it going up or down? Up would be positive infinity, and down would be negative infinity. So in this instance, they are going up. Additionally, I would look at as x approaches positive infinity. Positive infinity would be referring to my right arrow. Looking at this arrow over here. What's actually happening to the arrow? Is it going up forever or down forever? This one's also going up, so it would be approaching positive infinity again. So this first part on the left, as x approaches negative infinity, is literally referring to the left arrow every single time. And then here, as x approaches positive infinity, literally referring to the right arrow every time. So I'm going to go down here. So this one is talking about when I have an even degree, so like x squared, but my leading coefficient is negative, so it's like negative x squared, a quadratic that's upside down. So x approaches negative infinity, y approaches, that's what we need to figure out. X approaches positive infinity, y approaches, that's what we need to figure out. So basically looking at my left arrow, is it going up or down? Notice it's going down, so that'd be negative infinity. And again, looking at my right arrow, is it going up or down? It's going down, so again, positive infinity. One thing you'll notice about even degrees is that they're both go in the same direction, either both up or both down. That really depends on your leading coefficient. Let's move forward a little bit. As x approaches negative infinity, y approaches, x approaches positive infinity, y approaches. This is how you start writing all of them. Approaches positive infinity, y approaches. So what I'm going to do is use my cubic, for example. My positive cubic, my parent function, goes like this. Notice it goes up from left to right. I could say my left arrow is going down and my right arrow is going up. I'm going to pause here.